In this example, we're going to be finding the inverse of the following 3 by 3 matrix. First row is 1, 1, 2. Second row, 3, 1, 0. Third row is -2, 0, 3. The technique that we're going to use for this is referred to as the Gaussian technique. We start with A, we augment with the identity matrix, and we take the result down to reduced row echelon form. If in reduced row echelon form to the left of the augment we have the 3 by 3 identity matrix, then that means that what we'll have to the right of the augment is going to be our inverse matrix. Now this is not the only technique for finding an inverse, but we'll be investigating that later in the semester. So we'll start by setting up a 3 by 6 matrix. So 1, 1, 2, 3, 1, 0, and -2, 0, 3 will go to the left of the augment. And to the right of the augment, we're going to be putting the identity matrix in the form of 3 by 3. Now, in order to obtain reduced row echelon form, normally the first thing we do is get a 1 in the 1, 1 entry. I see that in this case we already have that done. So the next thing for us to do will be to use that lead 1 to get zeros in the 2, 1 entry and the 3, 1 entry. So the operation I'm going to have us do, well, operations, there will be 2 of them. We'll take -3 times the first row and add it to the second row to zero out the entry of 3 as the 2, 1 entry. For the -2, we will want to add +2 to that, so we'll take 2 times the first row, add it to the third row, and that'll become the new third row. So overall, the first row is not changing. It'll still be 1, 1, 2, 1, 0, 0. Then we'll take -3 times the first row, add to the second row. -3 times 1, add to 3, we get 0. -3 times 1, add to 1, we get -2. -3 times 2, add to 0, we get -6. Then we'll take 2 times the first row and add to the third row. Oh, sorry, need to do it to this part as well. -3 times 1, add to 0. -3 times 0, add to 1. And -3 times 3, -3 times 0, add to 0. That'll be 0. Now we'll take 2 times the first row and add to the third row. 2 times 1, add to -2, we get the 0 we were trying to get. 2 times 1, add to 0, we get 2. And 2 times 2, add to 3, we get 7. Then we'll take 2 times 1, add to 0. 2 times 0, add to 0. And 2 times 0, add to 1. I'm actually going to go just a little bit out of order here. Normally, the next thing we would try to do is get a 1 into this entry so that we can get zeros above and below it. I notice, though, that because we have a -2 and a +2, things are going to work out really, really nicely if I were to skip one quick step. And that's going to be to take row 2 and add it to row 3 with the intent of zeroing out the 3, 2 entry. We were going to have to do that eventually, so might as well do it. So with that in mind, first 2 rows will stay exactly the same. 1, 1, 2, 1, 0, 0 for the first row. 0, -2, -6, -3, 1, 0 for the second row. And now we're going to add these 2 rows together. 0 plus 0 will give us 0. -2 plus 2 will give us 0. And -6 plus 7 will give us 1. -3 plus 2 will give us -1. 1 plus 0 will be 1. And 0 plus 1 will be 1 as well. Augment goes right here. So, unexpected side effect of all of this, we actually got a 1 into the 3, 3 position as well. So this is working out just fine. Now let's go ahead and get that 1 that we were going to get from the previous step. And we'll take -1/2 of the second row and have that become the new second row. Still on camera? Let's move it up a little bit. There we go. So first row is going to stay the same. 1, 1, 2. 1, 0, 0. We're going to take -1/2 of the second row, though. -1/2 of 0, -1/2 of -2, -1/2 of 6, Negative half of negative 3 will be 3 halves, so we have officially introduced a couple of fractions. I believe that these were inevitable on this one. Imagining the fraction showing up with the infinity gauntlet saying, "I am inevitable." Now at this point, the next tasks in front of us are going to be to get zeros in all of the entries above our two other leading ones. The order in which we do so isn't going to be horribly important, so I'm going to go ahead and get my 0 in the 1, 2 entry first. So we want a 0 here. The way that we can do so is using that lead 1 in the 2, 2 entry. We'll take negative 1 times this row to add to the first row. So negative row 2 added to row 1. That'll become the new row 1. So overall, second row is remaining the same. Third row is remaining the same. And we're going to take negative 1 times the second row and add to the first row. Negative 1 times 0, add to 1. Negative 1 times 1, add to 1. Negative 1 times 3, add to 2. Negative 1 times 3 halves, add to 1. That'll be negative 1 half. Negative 1 times a half, add to 0. That'll give us positive a half. And negative 1 times 0, add to 0. No problem. Two more elementary row operations will get us to reduced row echelon form. And that will be using the lead 1 that we have in the 3, 3 entry to get zeros in the entries above it. So for the second row, we'll need to take negative 3 times the third row, add to the second row, and that'll become the new second row. And then we'll take positive 1 times the third row, add it to the first row, and that'll become the new first row. So overall, third row is staying the same, 0, 0, 1, negative 1, 1, 1. Let's do the second row. We'll take negative 3 times 0, add to 0. Negative 3 times 0, add to 1. Negative 3 times 1, add to 3. Negative 3 times negative 1, add to 3 halves. That'll be 9 halves. Negative 3 times 1, add to negative 1 half. That'll be negative 7 halves. And negative 3 times 1, add to 0. That'll be negative 3. Next, we'll take the third row and add it to the first row, and we'll see what we get. 0 plus 1, 0 plus 0, 1 plus negative 1. Now we have our identity matrix to the left of the augment. Negative 1 plus negative 1 half. That'll be negative 3 halves. Negative 1 times, or excuse me, we're just adding them together. Just add them together. Okay, 1 plus a half. 3 halves. And 1 plus 0, that'll give us 1. So final answer for this one, we can interpret this as A inverse is equal to negative 3 halves, positive 3 halves, 1, 9 halves, negative 7 halves, negative 3, negative 1, 1, 1. Now if you're interested in verifying these results, we can certainly use a calculator to do so. So I'm going to break out a calculator, since I always seem to have one handy. I'm going to input the original matrix that was given to us in this problem. So second followed by matrix. I'm going to edit matrix A. I still want a 3 by 3 matrix, but now I want it to be the original matrix that was given to us in this problem, which was 1, 1, 2, 3, 1, 0, negative 2, 0, 3. I'm going to double check, make sure everything got inputted correctly. 1, 1, 2, 3, 1, 0, negative 2, 0, 3. Okay, I think we're good. Then selecting matrix A and pressing the inverse button, which is the same button that gets you into the matrix menu, this will now calculate the inverse for us. However, my final answer is in terms of fractions, so I'd like to see fractions in the final answer as well. I'm going to press math, followed by enter. This command will convert everything that is a fraction into a fraction for you. Converting that, we see negative 3 halves, 1, 9 halves, negative 7 halves, negative 3, negative 1, 1, and 1. at which point we say, oh, thank goodness it worked correctly. I would have been so embarrassed if I had gotten that wrong.